This is the second Match 2 online class for class 10 student of BOSEM Public Academy. We are doing the same exercise 10.2. Today we will be working out two questions. The first one is textual question number 11. Question is, from the top of a tree 9 meter high, the angle of elevation of the top of a building and the angle of depression of the foot of the building are respectively 45 and 60 degree. What is the height of the building? So first let's draw figure. In our figure, AB represent the building and here CD represent the tree which is 9 meter high. Now observer is at the top of this tree 9 meter high, and from the top of this tree looking at the top of the building which is A, looking at the top of the building A from the top of the tree, angle elevation is 45 degrees. So this angle is 45. From the same position that is top of the tree, observer is looking at the foot of the building which is B. Since it is looking downward, the angle of depression here is 60 degree. So we let A, B and CD represent the building and the tree respectively. Then CE is parallel to BD is drawn, meeting AB at E. Now we draw CE which is parallel to BD, and this CD is meeting AV at point E. Then CD length is equal to now BE length. Since CD is 9 meter, BE is also 9 meter. Then before we go further, we have to find the height of building which is AB. To find AB, we already know now BE length which is 9 meter. So we have to find just AE length. If we know AE length plus BE length will give AB which is height of the building. Then like the previous question, we get two right triangle in the figure, and from this two right triangle we'll try to get two equation. So here the first right triangle we consider is BEC. You can see BEC, this is the first right triangle, and in this triangle angle is 60 degree. For this 60 degree, BE is opposite size, CE is adjacent size. So again we'll write in terms of tan. BE by CE, which is opposite by adjacent, is tan 60 because angle is 60 degree. And you know the length of BE is 9 meter, so we replace BE by 9, and tan 60 value is root 3. So cross multiplying we get CE is equal to 9 by root 3. 9 by root 3. And again finally we get CE is equal to 3 root 3. That is equation number 1. But now you may have doubt how we get 3 root 3 from 9 divided by root 3. For this it is worked out in the rough column. 9 by root 3 is equal to, now you can see denominator root 3 is irrational number, so we have to make this a rational number by multiplying another root 3. Then we multiply for numerator 9 also root 3. Then you know root 3 into root 3 is 3. Then we cancel this denominator 3 and numerator 9. 3 is 9, so we get 3 root 3. Then let's consider the second right triangle which is AEC. AEC. In this right triangle angle is 45 degree. For this 45 degree, A is opposite size and again C is adjacent size. So again we write AE by CE, opposite by adjacent, is equal to tan of angle 45. Tan 45 value is 1. So cross multiplying again we express for CE. CE is equal to AE now. This is the second equation. Now comparing the two equations, you can see comparing the two equation number 1 and number 2. Equation number 1, C is equal to 3 root 3. Equation number 2, C is equal to AE. In both equation you can see left side CE, they are equal. So from equation 1 and equation number 2 we make the right side also equal. AE is equal to 3 root 3. Then this is the value of AE, and you have seen in the figure, if you know AE, adding AE and BE will give us AB. So we directly write AV is equal to AE plus BE. AE length and BE length are 3 root 3 and 9. Adding them together we get 9 plus 3 root 3. But here we just change the terms. We used to write number without any root first, followed by the number having root. So height of the building is 9 plus 3 root 3 meter. That is your answer of number 11. Let's do one more question, which is textual question number 20. The question is, the angles of elevation of the top of the tower from 2 points at distance A and B from the base and in the same straight line with it are complementary. Prove that height of the tower is root over AB. So before we start the solution, let's try to understand what are complementary angles. Complementary angles, two angles whose sum is 90 degree. Complementary angles are two angles, when we add them we should get some 90 degree. Then here example is given, 30 degree and 60 degree are complementary angles, because 30 degree plus 60 degree is 90 degree. And suppose you know only one angle, let's say the first angle is 30 degree, and how to get this 60 degree? If you know the first angle, you just subtract that first angle from 90 degree, that is 90 minus 30, then we will get the second angle, which is 60 degree. So if you know first angle, you just subtract that first angle from 90, then we get the second angle. Like that, if we don't know both the angles, taking the first angle to be theta, the second angle will be 90 minus theta. Then now coming to the solution. Now we take AB to be the tower, then A is the top of tower, B is the foot of the tower, and C and D be the 2 points of observation on the ground level. Then now observer is looking from this point C and D, looking from point C at the top of the tower, and looking from point D at top of the tower. Here we have two angles of elevation, and these two angles are complementary. So we take this first angle theta, then the second angle is 90 minus theta. And also the distance of these 2 points from the tower are also given, small a and small b. So distance of this point D from tower we have taken small a, distance of point C from the tower we have taken small b. Then let AB represent the tower, C and D be the 2 points which are at a distance of B and A respectively from the tower. And like the previous question, again you can see here two right triangle. Now we consider the first right triangle to be ABC. Right triangle ABC, this bigger triangle. In this triangle we have angle C, which is theta. For this theta, AB is opposite, BC is adjacent. So we write tan theta is equal to AB by BC, opposite by adjacent. And you can see the length of BC is small b, so we replace BC by small b. Then cross multiplying we get AB is equal to B tan theta. That is equation number 1. Now for the second equation, consider the another right triangle ABD. For this right triangle ABD, angle is 90 minus theta, which is angle D. For this angle, AV is opposite, BD is adjacent, and the length of BD is small a. So the second triangle, in triangle ABD, angle is 90 minus theta, so we express in terms of tan, then opposite by adjacent, AB by BD. The length of BD is small a, we replace it, and you know according to complementary angle relation, tan 90 minus any angle is equal to cot of that angle, cot theta. So tan 90 minus theta is equal to cot theta. Then cross multiplying we again express for AV is equal to A cot theta. That is equation number 2. And in this question we are asked to show that height of the tower is root over AB. That means here we have taken AB to be tower. Then what we have to show is AB is equal to root over AB. Now imagine what could be the step just before this. It could be AB squared is equal to AV, because from this AB removing square, right side small a small b will come under square root. Then how to get this relation? Now for this, again compare the two equations. Equation number 1 and equation number 2, we have AB left side. Here also equation number 2, we have AB. So if we multiply equation number 1 and 2, AB into AB, we will get AB square. So now we multiply the two equations. Multiply equation 1 and equation 2. AB into AB, right side are A cos theta and B tan theta. AB into AB is AB square. Then is equal to A cos theta into, now we write tan theta as 1 by cot, because tan and cot are reciprocal of each other. Then cot theta and cot theta we cancel them. Then finally we have only small a and small b. Then we remove square from left side. Then we get only AB. Since we remove square from left side, right side expression comes under square root. Then this is the value of AB. AB is nothing but building. Thus height of, sorry, not building, height of the tower. AB represent height of the tower. Height of the tower is root over AB. In this question, actually question is asked to prove height of the tower is root over AB. The same question can be asked to find height of the tower. Even if the question is to find height of the tower, height will be root over AB. That means we have to do it in the same way. Okay, that's much for today.